Hola, buenos días o buenas noches, según corresponda. Yo soy Horacio Pérez y os doy la bienvenida al podcast Investigando la Investigación, el podcast donde hablaremos sobre temáticas muy relevantes dentro del mundo de la investigación, como en qué temas actuales y de impacto se está investigando en todo el mundo, cómo llevan a cabo su investigación los investigadores y cómo es su vida y día a día, qué les motiva a investigar y qué problemas encuentran y resuelven para poder seguir adelante. Y además nos centraremos no solo en la investigación académica, sino también en la transferencia tecnológica y en cómo se realiza la investigación en las empresas.
Hola, hoy es miércoles 30 de marzo de 2022 y hoy os traigo un episodio que es continuación de otro anterior que tuvimos a principios de diciembre de 2021 pasado y en donde os contaba la idea de lo que es un Journal Club, que básicamente es una manera de planificarse y motivarse para crear una discusión en torno a publicaciones científicas y entonces uno se motiva para poder estudiarlas con mayor digamos, impulso, como si dijéramos, y luego lo que motiva mucho más todavía es cuando se realizan esas discusiones en grupo acerca del paper que se decide leer para esa sesión. Se podría ver un poco como un club del libro, pero en este caso nos centramos en un paper. Bueno, pues en ese episodio de principios de diciembre de 2021 explicábamos cómo hemos implementado nosotros un Journal Club, en este caso online, a través de nuestro servidor de Discord, nuestra comunidad de Discord de bioinformática computacional y alto rendimiento, donde hablamos de todos esos temas en inglés y donde estáis invitados obviamente a participar y uniros. De hecho, os lo recomendamos fervientemente. Entonces, en ese episodio estuvimos comentando un paper de Pablo Arantes, que es un investigador de la Universidad de California, Riverside, y donde nos comentaba cómo había implementado una manera para explotar de manera gratis recursos de cómputo GPU que nos proporciona, o que digamos proporciona no de manera evidente Google, a través de su plataforma Google Colab. Entonces él ha encontrado una manera para poder ejecutar simulaciones de dinámica molecular, de plegamiento de proteínas, principalmente. Pero muy interesante porque esta idea se puede abrir a muchos otros tipos de simulaciones. Entonces lo que os voy a poner ahora es íntegramente la discusión, debate, aprendizaje, preguntas que tuvimos ese día con Pablo Arantes, y además a esa Journal Club se unieron otros miembros de nuestro grupo de investigación y también otros miembros de la comunidad de Discord que les apeteció unirse ese día. Entonces nada, os la paso a continuación. Está totalmente en inglés, pero como os he dicho otras veces y lo seguiré haciendo, es un inglés técnico, y si os interesa el tema de computación en general, bioinformática estructural, yo creo que es bastante fácil de seguir. Pues nada, vamos a por ello y espero que os resulte interesante. Hi everybody, we have today in this Journal Club, this is 1st of December of 2021, and we are going to talk today to have this discussion, this Journal Club, about the paper Making It Rain, Cloud-Based Molecular Simulations for Everyone, from Pablo Arantes and collaborators. Hi, Pablo, how are you?
Hi, Horacio. I'm fine. Thank you for the invitation. It's a pleasure to be here and talk with you. And I hope I can help you with the questions and all the explanation about our work.
Sure. And thanks a lot for accepting this invitation. I'm going to introduce some of the other members. We also have here today Alejandro Rodríguez Martínez, Miguel Carmena Bargueño, and Sabine Puertas Martín. We are working together in a lot of projects in the Bio-SPC group. So hi, Miguel, Alejandro, and Sabine. And we also have Glorister Alte. Can you introduce yourself, Glorister?
Hi, I am a master student at UFSC in biochemistry, and I work with bioinformatics, structural bioinformatics.
Okay, thanks.
With Professor Guilherme Razer.
Okay, thanks a lot for the introduction and for being here. We also have Curro Campuzano. Curro, can you introduce yourself, please?
Yes, I'm a biotechnology student from Granada, Spain, and I'm currently working in a bioinformatics internship, and I'm really glad to be here.
Okay, thanks a lot, Curro. And Alejandro, can you introduce yourself, please? Alejandro Rodríguez.
Yes, I'm a student that finished your master degree of bioinformatics in Universidad de Murcia, and now I'm working and collaborating with Horacio and the other investigating in bio HPC in UCAM.
Okay, thanks a lot, Alejandro. And then we have hi, Miguel. Can you introduce yourself?
Hi everyone, I am Miguel Carmena. I am a PhD student of the UCAM in the group of Horacio and BHPC, and I'm working with molecular dynamics, and this is because it's very interesting, this meeting. Thank you a lot for do this.
Thanks, Miguel. And we also have here Sabines Puerta Martin. Can you, Sabines, please introduce yourself?
Yes. Hi everyone. Can you hear me?
Yeah, perfectly.
Okay. Yes. Well, I'm Sabines Puerta Martin from the University of Almeria, and I'm currently a postdoc there in HPC too. And as Horacio said, we are working. Well, he was my supervisor in my PhD, and we work together.
Okay, thanks a lot, Sabines. And we also have Brinda Verapan. I don't know if I said the name correctly. Can you, Brinda, introduce yourself? Okay, it looks like there's no connection now. We can introduce perhaps Brinda later. Okay, so we are here now. We did all the presentations. So briefly speaking, the work that Pablo Arantes did has been published in a very reputable journal, Journal of Chemical Information and Modeling. And Pablo, can you briefly tell us in 2 or 3 sentences what your paper is about?
Sure, absolutely, Horacio. Before I go further, I just want to introduce myself. As Horacio said, my name is Pablo Arantes. I am from Brazil. I did my master degree and my PhD with Professor Hugo Verli in the south of Brazil, in the Porto Alegre city, and the Federal University of Rio Grande do Sul. And after that, I did 1 year of postdoctoral research there in the same city. And in 2019, I moved from Porto Alegre to Riverside, California, where I am now as the position with postdoctoral research, working with Professor Julia Palermo at the University of California, Riverside. So back into the paper right now. Can you please repeat the question, Horacio?
Yeah, please. Okay, well, just before, because I'm very curious. How did you apply for a position there in the group of Julia Palermo, or you got a fellowship? I mean, how did you get this position before we go into the paper?
Yeah, before I finish 1 year of postdoc in my city, in Porto Alegre, as you know, the Brazilian funds for science, it's a very issue now, a very huge issue now. So I was looking for a position, an entire world, and then Professor Julia Palermo had this position available. So I sent my CV and my cover letter to her, and then we discussed a meeting. We had a meeting. We discussed a lot, and then in the end, she hired me.
Mm-hmm.
And it was very good because Professor Julia Palermo works in my field with molecular dynamic simulation and enhanced MP methods and so on.
Okay, excellent to know. Okay, and now going to the paper, can you briefly tell us in 2 or 3 sentences, which is hard, what your paper is about?
Yes, absolutely, Horacio. Our paper, because after I came here, I started to work with Jupyter notebooks to run codes in Python and doing analysis and so on. And at a certain point, I realized that we have this tool on Google Colab, and you have the option to use for free this tool, and you can run codes there inside of Google Colab. And then at a certain point, I realized, but if you can run a code, you can run a code from molecular simulation. And then I put these ideas together and I made some tests. And then in the end, it was doable. We can do the simulation on the Google Colab. And then I talked with my collaborators, the Dr. Marcelo de Paulo Poleto. He's working at Virginia Tech here in the United States. Dr. Conrado Pedebos, he's in Oxford, and Professor Rodrigo Ligabui Brown. He's professor in the south of Brazil in Federal University of Health Science. And we discuss together and we look at in the literature, and we have seen that there is no work like that. No one did that, this type of approach where you have a cloud computer and everyone can use with your Google account and your Google Drive. And then we had this idea and I say, I think we can put everything together. You can have, a code ready for everyone to use. But even if the people are not able to go deep in the code, people can use just to run molecular simulation. Was our initial idea. And then we discuss a lot. And then we sit together and put the code together. And in the end, we had a good approach for that.
Yeah, thanks. Very, very interesting. I remember your paper was published sometime in the summer, June, July or something, and it was very. It got a lot of mentions. I remember through social networks, and so I guess you are happy that a lot of people know now your work, right?
Yes, because Horacio, the point is, as I said before, when I arrived here in Riverside and worked with Professor Julia Palermo, we started doing analysis on Python on Jupyter notebooks using basically the PyTorch or MED analysis. It was great. Why it was great? Because you can run, a lot of analysis at the same time in a very efficient way. You see my point? And then when I realized I can use Google Colab and can run simulation and perform analysis inside of Google Colab, I think, can you imagine that a third world country, where they don't have access to HPC? So it's hard to them to work with molecular simulation. I have a good publication and so on. And then I realized that if you pay, here is $10 per month, you can have pro access, and then you can run simulations in a very efficient way. We can reach 1 microsecond with this, at least a system with 50,000 atoms, maybe with 100,000 atoms. In 1 month, we can reach 1 microsecond of simulation. And then when we are discussing, we realized this tool has a huge potential for our community, but not only for here in the US or Europe, but for the third world countries, even in Brazil. I hope the people are using a lot, because this is our initial idea was to help with this tool. And not only that, for educational purpose, it's very important too, because can you imagine if you are doing a class of molecular dynamic simulation and you need to install Linux in all the computers, you need to compile all the software, GROMACS, Amber, and so on. You need to compile. And with this tool in Google Colab, it's one click. You can install everything in 5 minutes, 7 minutes, and it's done. And you can run.
Very interesting.
You can share your notebook with your students. They can open even in a tablet or a cell phone.
Right.
And you can have you can run simulation with them and explain what is happening and so on. It's very useful.
Okay. And one question: when you, I think before the journal, you submit to a preprint server the paper, right?
Yes, this is an excellent question actually, because our paper was released after AlphaFold. You remember that they released AlphaFold and they released AlphaFold on Google Colab. And then some people, there are some people that they are thinking that we have been using the same approach because of AlphaFold and Colab, but it's not true.
Okay.
When I started using Colab to run simulation, and when I was doing some tests, it's on May, and that.
Right.
But at the same point, they released AlphaFold, and then they released the AlphaFold and Colab. So when they release AlphaFold and Colab, we are very afraid of the people is going to realize that the Google Colab is a very useful tool, and you can run dynamics there. So then we start to finish very fast the paper to publish as a preprint, as you said, and then we submit to there's a preprint server, the Zinode, and then submit there the code and the paper, because otherwise the people is going to realize that no, you can use Google Colab not only for AlphaFold but for several things as machine learning, but for the molecular installation too.
Okay. And anybody has some question now? Anybody wants to add anything? Okay, I'm curious. I think that's a very good strategy. Okay, because there is a lot of things involved here. I mean, it's the science, it's the technology, but sometimes there are many different things around. Like you said, people think that DeepMind and everything that you said. But I'm also curious. You have your code. Your code is hosted in GitHub, right? And
absolutely.
Can you get some metrics or some idea about how many people are using or getting this code?
Yes, actually we have it. We have in the website, we have Google Analytics to have a metrics, how the people are assessing that. But there are one issue actually with that. In the beginning, we have this boom with a lot of people using and assessing and so on. Okay. But right now, I think people just saving and the favorites, and that's it. There are people that are not assessing anymore. So that sometimes when for example, last month, no, actually in October, we are in December now, October, we released a new version with 3 more new notebooks, and we have a boom again. There are a lot of people assessing and so on, and then now it's starting to decrease again. We have in the GitHub, we have, for example, if I enter in GitHub right now, we have 123 stars and 28 people fork the notebook. But if I enter in the insights where I have the traffic and so on, let me see if I can find. Yeah, we have more than 1,000 access.
1,000 access.
It's great. But the good thing of this code, if you don't know how to code, you just can use, because it's point and click. You can upload your files to Google Drive. So it's good for the people that are in the beginning of the process to learn molecular dynamics simulation and start your work. And not only that, but if you know how to code and you want to do more than we have there, you can go deep in the code and change the code and run. I don't know, you want more analysis and want to change the parameters of your simulation, you can go deep in that and can change.
Right. I think that's one of the very interesting points here. And now I would like to take 1 minute because we went directly into all the technicalities, which is necessary. But for the audience, the people that are not very familiar with this, as Pablo said, Google Notebook. Google Notebook. This is really Jupyter Notebook, the kind of framework or whatever that you can call it, which allows very easy use and understanding of code. And this is one of the technologies that has been used here. But regarding Google Colab, and when do you know exactly when it became available? Was this year, last year?
Google Colab, no, I think this is an excellent point you said. We need to explain for the people. We are using Jupyter Notebook. Jupyter Notebook, it's you can use in your personal computer, in your laptop, and you can run codes as a cell. You have a cell, you run the cell, you have the output for you in your screen. Okay, it's very good tool. It's easy. You can use. However, you need to run in your local computer. When you are using Google Colab, what's the difference? You are allocating a virtual machine on Google GPUs.
Mm-hmm.
So we are not using the resource of our laptop. We use the resource from Google, and Google has a very good GPUs to run run simulation or to use for machine learning and so on. That's the main difference between that. Okay. When they released the Google Colab, as far as I remember, it's on 2018. They released this code, but I think in the beginning it's only for the United States, and then the next year they release for India, Brazil, UK, United States, and some countries in Europe. Okay. And that's the thing.
Okay, we have a question from Glorister. She says, what kind of simulations can be done on Google Colab using this code? Proteins in water, proteins and small molecule ligand, protein in cell membranes. Can you answer this?
Actually, absolutely. This is an excellent question, actually, because the point is you can do whatever you want, actually. Why I'm saying that? Because we have 6 notebooks there. The first one is protein in water. Okay, the simple one. Okay. Mm-hmm. The second one, we are using the Charm Guy inputs. When you have this website from Charm that you create your inputs and then you have your output, your topology ready, the server, you can use the inputs for Charm Guy, and then you can input in our notebook and run. And the third one, we are building the model with AlphaFold, and this model is going to be used to run simulations. Okay. The fourth one is protein with ligand. You can run the protein and ligand system and Amber force field and GAF force field. Not only that, and OpenFF for the ligand too, if you want. You can have analysis of PBSA. We have analysis of interaction energy. We have analysis of the RMSD, RMSF, and PCA. And there are the last 2 notebooks are very interesting one, because the one of them is on Gromax. You can prepare your system on Gromax, and then you have your top and your GRO, and then you just submit to our notebook and you can run.
Okay.
There are the last one. Another one is you have your inputs on Amber. You prepare your system on Amber software. Just input your Palm top and your CRD, and you can run. So if you prepare your system in Gromax, I don't know, a protein with membrane and so on, and you have your top and GRO, you can submit there and run. That's my point.
Great. Excellent. Thank you. And Glorister has another question. She says, is it easy to use or is it too complex? This is the $1 million question.
That's a good question too. As I said before, if you don't know how to code and you just want to use, just go there, enter, and it's a point and click approach. Mm-hmm. You see, you run the cell, you select the parameters. What is the parameters? First thing you should do is connect your Google Drive account, and then you submit your files there in your folder, and then you should put the path of your folder in your Google Drive, and that's it, and the name of your files, and then run. And the next step, you're going to select the force field parameters. I want Amber 99 as SB. And then I want the concentration of ions of 0.15. Okay, and then run. You're going to have your topology. And that's it. It's point click. If you don't know how to code, this is not an issue. Just go there, change the parameters, and run.
Okay, but just for the audience, I guess we need to tell them that, of course, somebody must prepare kind of a first version of the code, right?
Sorry, Horacio?
Yeah, I mean, you put some examples in your GitHub repository. You have some examples that the people can easily get and run on the notebooks. Okay, they can run them just with all the default parameters. If they want, they can modify some parameters. They can dive deeply into the code, but they also have the option to start from scratch, right?
Absolutely, they have the option to start from scratch. If you want, you can change whatever you want. Even on the molecular dynamics parameters and the equilibration part and the production part, you can select the time step, you can select the temperature, you can select the form constant, everyone. But it's not in deep in the code. It's point and click. You have the options there.
It's
just
point
type.
and click. Right.
Yeah, it's point. Just type there. I want temperature 300 Kelvin. You type 300 and then run the cell. It's very easy.
Okay, very interesting. I think this can lower the barrier for access to most molecular dynamics codes, because most of the times it's really complex for beginners to get into this, given all the thousands of parameters the one needs to learn. So yeah,
exactly. That's the initial idea. We wanted to keep there all these parameters in a fashion way, in an easy way to people understand what they need to change, and why they are changing that. They can go in literature, understand what is happening. But if you want to change it, it's easy. It's not so hard to change things and so on.
And another question, let's suppose somebody wants to use either GROMACS or OpenMM or some other software. This software must be kind of pre-installed on your system, or how does it work? Just a general question for the audience.
Yeah, as I said before, this is another good question. As I said before, Google Colab, you are locating a virtual machine on Google, okay? Mm-hmm. So every time you enter, the first cell, if you look the notebook, the first cell is going to be install dependencies.
Okay.
So you run the cell, it's going to take 5 minutes, I think 7 minutes. Depends if you're using the free or pro. So 7 minutes and everything is installed for you.
Okay.
And then just run the next cell. Okay, if you're disconnected and you run again, you just enter again and run the cell again. But that's the whole point. We have been using the OpenMM, because OpenMM, it's free. Of course, it's on Python language. And with one line, conda install -c, you can install the OpenMM, and it's fast to install. It's fast when you compare. For example, GROMACS is an excellent program. It's an excellent software. I have been using a lot GROMACS. However, if you can install on Google Colab GROMACS, but it's gonna take 35 minutes.
Right. Yeah, exactly.
You can imagine every time you disconnect, it should run again 35 minutes. No, just with this approach, you just click and then you can run. In 5 minutes, you have all the dependencies installed for you and just run the next steps. And not only that, the OpenMM is implemented only on GPUs.
Only on GPUs, right?
So in Google, the main power you have is on GPUs. You have a Saxon 1 GPU on Google, and it's a powerful GPU. And then when you run the OpenMM, they are using all this GPU processor.
Okay.
You're not using CPUs. That's my whole point.
Right. Yeah. Just for the audience, GPU, it's about graphics processing units, and this is just to make the long story short, is a very powerful processor that can run some kind, not all the simulation, but some specific types of molecular simulation much faster than in a regular processor. Okay, so we have one question from Curro Campuzano. He says, how important would you say GPUs are in processing time? And are the algorithms running behind the notebooks optimized to use GPUs? What do you think, Pablo?
Yes, exactly. That's the reason we have been using the OpenMM, because all the code of OpenMM that we have worked, he works on GPU. He is optimized only for GPUs. Okay, so it's run very, very, very fast. It's incredible fast on GPUs. This code OpenMM. That's the one reason we are using OpenMM and are not using Umber or are not using GROMACS, because GROMACS it's using CPUs plus GPUs. It is still a little bit tricky to use GROMACS only with GPUs, and OpenMM is very flexible. I mean, we build the code, it's there, but if you want, you can change, and there are a lot of options, and it's fast, and it's allowed you to use several types of different inputs. And the best thing you can use in GPU, if you take a look on the paper, you can see our benchmark, and it's really incredible how fast is on GPU this OpenMM. for example, if you have a system with 100,000 of atoms, you can run 15 seconds per day.
Wow.
In GPU, it's incredibly fast.
Okay. And Curro also says, are the algorithms optimized to use GPUs? The answer, I guess it is yes, because as Pablo said, OpenMM, I have the feeling that it has been designed thinking completely on GPUs, right?
Absolutely right. They you can use on CPUs if you want. They're optimized for CPUs, but the best thing on OpenMM is using for GPUs.
Okay, just curious. Does OpenMM come from the group of Vijay Pandey, the one from Falling at Home?
It's a good question.
I remember something.
Yeah, because the thing is, OpenMM it's an open tool, it's an open platform, and there are several groups that are working together on this. In this, let me see. It's from Professor John Codera.
John Codera, okay.
Yeah. They are using a lot of OpenMM and Open Force Field too, and I think they are one of the main developer of that.
John Codera did PhD with Andrew McCammon. Probably I don't know.
Maybe it's a good question, but I don't think so. For us.
Okay, just curious. I'm very curious. Okay, so more questions from the audience. I have one question here, Pablo. Let's suppose all the codes, let's say all the molecular dynamics codes, OpenMM, GROMACS, Amber, whatever, they had exactly the same GPU performance, kind of, I don't know, 200 nanoseconds per day, but exactly the same performance. Then which one would you use for molecular dynamics simulations?
Right now, if it's a tricky question, but right now, if I can choose, as I'm using OpenMM, I can say for you that I prefer OpenMM.
Really?
Because I think it's flexible. You see my point?
Yeah. Okay.
You can flexible. Change. You have the option to change more things in the script and the code, and your freedom to do whatever you want. You know?
Yeah, but for instance,
tell me. No, tell me.
If you compare it with GROMACS, in GROMACS you also have access to the source code. There is a lot of documentation. So in GROMACS, the headline is I remember GROMACS fast, flexible, and free. So GROMACS is supposed to be flexible.
Exactly. So. But the things on GROMACS, for example, right now we are working Python. Okay, GROMACS, you have access to source code. You are right. However, you are using Fortran.
Okay, right.
Yeah, it's not. I think it's a little bit more tricky to change the code on GROMACS than you were using OpenMM. That's my point here.
Okay.
And
that's an important point. Of course.
Yeah, exactly. But for sure, GROMACS it's an excellent tool. I'm not saying that GROMACS is not an excellent tool. I'm saying for that case, for cloud computer, OpenMM fits way better in that case for several reasons.
And some other question from the audience. Miguel, Alejandro, Sabines.
There are one important point for us to say.
Right.
We are talking about Google Colab and cloud computing and so on, but there are you need storage for that thing, right? You can ask me, but where are you going to storage all this data that you are creating on Google Colab and cloud computing? So that's the reason. That's another good thing to use in Google Colab, because you can link your Google Drive account, and then in our notebook it's gonna save it automatically all your outputs on Google Drive.
Okay, yeah, that's a very important point for the people that don't know. So you connect it with your personal or institutional even Google account, and you can use that as storage. Is that the point, right?
Yeah, that's exactly the point.
Okay, so we have a question from Miguel. How many runs can you run in parallel with Google Colab?
This is excellent point. On Google Colab, you can run 2 tabs at the same time. So you can run 2 jobs at the same time.
2 jobs at the same time.
Yes.
Okay.
Okay. You can use the 2 GPUs at the same time in Google Colab. So, for example, it's not too much. You cannot use 10 tabs running. Now you can use 2. Yeah. There are limitations, but at least you can run. For example, we made some tests before, and if you're running, 4 systems in your work, 6 systems, you can can reach 1 microsecond in 3 months. For example, in 1 month I can run 2 systems, 1 microsecond. Another month I can run 2 systems, 1 microsecond, and then in 3 months you have the results. It's not so bad, because if you think in AGPC, you need to stay in the line waiting for your job entered to run, right? Here you don't have the line. Just submit the job, it's going to run.
Yeah, okay. I think it's great because there is something very important that you said at the beginning, because this is free. This is free, and people from what it's called third world countries can use it very very easily. So that is a very important point. But another question I have is, you have access to 1 or 2 GPUs per, and this is connected to your Google account. So
exactly.
Can you somehow use several Google accounts? I guess. For sure. This is if you want, you can create, for example, 5 Google accounts, and you can use. You see, it's not an issue for sure. Yeah. Okay.
But yeah, it's good actually. But for example, you can imagine a small lab, as you said, in a third world country, that they don't have research, but they want to start with simulations. Then they can use this research and start some small systems and run some simulations. It's going to be great. It's one of the main idea when we started.
That is really important. And I guess, well, I don't know. I think nobody knows. Google is not going to kind of detect the IP address from 10 Google accounts from the same lab and ban them access. I guess they will allow to do things, right?
Well, yeah, exactly, because it's the same thing when you open an account for email on Google. You open several accounts, you have several email accounts, you're going to use the same account for using Colab. As you are using for Drive, you are using for Google Thoughts, the same thing. But right now you are running code on Google.
Okay. Very interesting. And yeah. Another thing regarding high performance computing, I read that Google incorporates into the Google Colab system access, incorporates TPUs. TPUs is a special kind of processor. I think it is tensor processing unit, which is deeply used for deep learning. I guess at the moment, as far as I know, and I didn't read out about this, cannot be used in molecular dynamics. I think this is mostly for machine learning, right?
Yes, you're absolutely right, because this is one point. When Google create this Google Colab, in the first, they create that for the machine learning users. Okay, and people are using that for machine learning for sure. They are using a lot. AlphaFold is an excellent example for that. And then people realize that they can use for another stuff, as molecular dynamic simulation or for analysis of the systems and so on. But TPU is for machine learning for sure. You cannot use a TPU for run simulations yet. I hope in the in near future we're gonna have something, it's gonna change. But I hope.
Let's see. But my point is, we programmed code on GPU some years ago, and I have the feeling this TPU is not completely kind of exploited, because not everybody has access to this, or nobody had access before. But I hope that with this Google Colab access, people will start to use it and develop new codes, and let's see what happens. Okay.
I got it.
Let's see. Okay, so some more questions from the audience. We have Sharanya Manoharan. Hi, Sharanya. Some more questions?
Okay, we have some question from Alejandro. In reference to storage, having 15 gigabytes of data in free version, can there be problems with storage when you are running simulations in these cases? I guess the question is, what happens when you get over the space, when you are running out of space? Is that the question, Alejandro? Yes.
Yes, exactly. This is a good point. On the free version of Google Drive, you have 15 gigabytes for sure. If you're running simulation, maybe you're going to have more than this data or not. But the thing is, what you can do, as I said, you can create a new account on Google Drive and use this account only for run simulations. And then when you are done with your simulation, you can download the data from your computer. Okay. Another thing, you can buy more space on Google, or the third option that the people are using the university account. They have unlimited space on Google Drive, on the educational account. That's the right word. So this is the option. But usually, if you don't have the unlimited account on Google Drive with the educational account, you can run the simulation, download the data for your computer, and then delete from Google Drive and start a new simulation. You see my point? Because when you run the simulation, you can select the number of strides and the number and how it's going to be the frequency that the script is going to record your frames.
Right.
You see my point?
Right, exactly.
So so you can select. I want to record at each 10 picosecond, at 100 picosecond, at 1,000, and then you can select a frequency that's not not going to have a huge trajectory. I mean, a huge size of trajectory, and then you're going to be fine.
Yeah, exactly. And do you know? Here you said it can connect to Google Storage, but are there other options? Kind of, I don't know. Let's say, Dropbox. I don't know if it can be connected, but I guess that with Dropbox, it will be very expensive.
This is an excellent question, Rasul. I didn't try to connect the Dropbox, but maybe they have some option on that, because it's see, I just made a search on Google, and then how to directly download files from Dropbox or Google Drive. Or Google Drive with terminal on Google Collaboratory. So you can. Seems that it's possible to link your Google Dropbox.
And sometimes you said, so people say that money doesn't give happiness, but in this case, I guess if you pay, this is we are talking now about the free version of Google Collaborator, but if you pay more, you have this Google Pro or Google Plus, or I don't remember the name. Then do you get an increase in what? In storage, in number of GPUs? What can you say?
No, the thing on when you have you said right. We have the Google free version. We have the Google Pro. It's $10, and we have the Google Pro Plus. It's $50. Okay. When you go to Google Pro, we are gonna have access to better GPUs.
Okay.
So it's a more powerful GPUs than Google Free. And then when you have access to Google Pro Plus, the difference is, this is the main difference. The Google Pro, you should open your browser, click, and run a simulation. But you should keep your browser open. Okay?
Yeah, exactly.
Exactly. When you have the Pro Plus, you submit your job and you can close your time. It's gonna continue to run. But that's the thing. You are changing the $10 to $50, so it's increased the price. You see, it's 5 times more, and it's way more than that. But if you are thinking in a third world countries, $10 per month, it's okay. I think it's okay for it's affordable for everyone. They can pay. Okay, and they can use a good resource. But then when we think in $50, and then you have this currency thing, it's going to be expensive.
Right, exactly. I guess this answers the question from Saranya Manoharan, right, Saranya?
Yes. If you can choose, I would like to use the Google Pro. I have Google Pro. I'm not using Google Pro Plus. I think it's enough for you. You can run simulations and everything's going to be fine.
Okay, great. More questions about price storage from the audience? No? Okay, I have a question. Well, I have a lot of questions, but this one is, do you use Google Colab at the end is kind of hardware to which you can connect using this Jupyter notebook and everything. But you said that when you, for the people that don't know exactly how it works, correct me, Pablo, if I say something wrong, but you need to open your browser, I guess Google Chrome, because we are talking about Google or anything else. You open your browser, you put there your notebook, and then you submit the calculation, but you must keep the browser open at the same time that you are running your simulation. That's what you said, right?
Yes, right.
Okay. So my question is it possible to access this hardware via like we do in classical high performance computing via SSH, so that we have no? Okay.
No, this unfortunately you cannot, because as I said before, you are using allocating a virtual machine on Google. So this is a temporary machine. You cannot have access. For example, I understand your point. You want to run and your workstation in the lab, and then you can access it at home to see if everything is running, right?
For instance, exactly.
Yeah.
Exactly.
No, you cannot do that. You cannot do that. This is tricky. This is a little bit hard, but what we usually do, that's the reason in our code we have this option. It was Marcel's idea. It's a very good idea, where we have the strides. What the stride means.
Exactly.
We suggest for the people that are using the Make It Rain, select a high number of strides with a small simulation time, because then you're gonna have, for example, if you want to run 200 nanoseconds, you can do 2 nanoseconds time for 100 strides. Okay, then you're gonna run in 100 steps. Why I'm saying that? Because if in the middle of the process Google disconnect for any reason, you have all these strides saved for you. You're not gonna lose your simulation.
Okay.
You see my point?
Yeah,
and
exactly.
That's the reason. Then you can connect again, and then you can restart from the point that you stopped it, because you have all the strides saved for you.
Okay. And I guess, as you said before, you need to optimize the time. I think you have studied and you reported on the paper that I read again this evening. Because the basic version gives you a maximum running time of 12 hours. So
yes, exactly. Sorry. I forgot to say. Sorry, I forgot to say the question about free, Pro, and Pro Plus. The difference is time too. On free, we have 12 hours running, and Pro we have 24 hours. You can run. So that's one of the main difference too. You can run for 12 hours, and then you should resubmit again. And in a Pro, you can run for 24 hours. But if you think in HPC, for example, here we have access to a lot of different supercomputers, and we have here the limit time for 24 hours too. So it's not so different.
Really, 24 hours, but that's just for GPU code or for everything?
No, for everything. If you're here, for example, here, if I use a supercomputer here for example, in San Diego, the time limit is gonna be 24 hours, and then your job is gonna be removed, and then you should submit again. Of course, we have a script. We're gonna keep the submitting every time the job is done, but it's the way that it works here.
Okay. Yeah, you need to adapt yourself to your system. Okay, thank you. More questions from the audience? Sabines, and any question from your side? Okay, so I have another question. I guess I'm feeling, and I could be wrong, of course, but I'm feeling this Google Colab thing is getting a lot of success now, and I hope that some potential competitors will start to do something similar, kind of. Amazon, I don't know, Apple, or I don't know, Microsoft. If you know if they are trying to do something similar in the same direction.
I'm praying for that, Horacio, actually, because when we are working on that and we are writing the paper, I looked on the internet for some similar tools for Microsoft, from Apple, and from Amazon, and nothing. The only thing that they have you can have access to GPUs from Amazon or from Microsoft Azure. But it's really expensive. It's not like that an easy tool you can access like Jupyter. No, you need access, and you should pay per hour the access, and it's really expensive. So I hope with the Google Colab and all this success and thing, I think that this company is gonna see, we have a potential tool on that. We should do the same, and then they're gonna open, because then you have several options to use. It's gonna be great. But now we're the only tool that we have is Google Colab, because the others are you should pay to use the GPU per hour. So, but it's very expensive. It's crazy.
Yeah. I know some numbers. And it's very. I remember something. We asked once Amazon, and just one high-end GPU, kind of Pascal 100 from NVIDIA, 1 month full time, kind of regular system, it cost $2,000 or something like that.
Yeah, this is exactly. This is insane. It's too much money. It's impossible. Yeah,
exactly. Okay. Yeah. So some more questions from the audience regarding price, storage. Okay, what I see is that it is a pity. It is great to have access to the GPUs so that you can perform molecular dynamics or other kind of molecular simulations. But I feel there is a gap here for just CPU simulations. Why do I mean that? Because there are many other molecular simulation techniques. Let's go for docking simulations and something where GPU software is not so extensively developed, and people from third world countries would be happy if they could run a simulation that require a lot of CPUs in such a way. But I don't know. I didn't see a kind of a Google Colab system where you can access 100 CPUs or something like that. You know something about this?
No, unfortunately, you are absolutely right. There's no this such a thing in Google Colab. When we have access in the same virtual machine that you open on Google Colab and have access, you have access in one GPU, and I think maximum is 8 CPUs.
8 CPUs.
Okay. That's it. I have seen people running docking calculations on Google Colab with several different algorithms, but they are using CPUs for sure, I think.
CPUs, okay. The CPUs, okay.
Yeah, good. But I don't know. Maybe it's not a huge virtual screening. Some just a few molecules on the docking systems. Right. Yes, but anyway, it's an excellent point. And it's still hard to have access to a lot of CPUs like that. I think that's people are still using the high performance computing for that.
Okay. And I don't know. I'm thinking about something. You said before that you need mandatorily to have your browser open, right? When you use the free version, right? It must be open. Okay, because I was thinking, why don't we kind of, if the process could be automatic, kind of just from scratch, I just open some Google email accounts, and I do some scripts that open the browser. That can be done as far as I know. And they submit the calculations. Perhaps I could escalate I would try to escalate the process in order to have many different Google Colab instances, but via scripts. Okay, I don't know if that can be done. The problem that I see there is that when you open, you cannot open, because this only works with Gmail accounts, I guess, right?
Yeah, exactly. You're right.
Okay, and you cannot use a script in order to open kind of 1,000 accounts. And okay, I'm thinking too.
The issue. I think you can, Horacio, but the issue I'm seeing here, the issue is you have to run the cells inside the code. You see my point? So when you run your script to 1,000 tabs you're gonna open to run Colab, you should emulate the people that are running the cells. You see my point?
Yeah. I see. I mean, I'm not trying to do something nasty here. Just wondering about the technicalities. Yeah. But I guess because here the bottleneck would be just pressing the buttons into the notebook, right? And that cannot be scripted or do a macro or something, right? Okay.
Yeah, that's the whole point. Yeah.
Point. Okay, we have a question from Curro Campuzano. He says, I think it could be done using Selenium, but it can be complicated. I don't know exactly what Selenium is. Curro, could you tell us with your voice what Selenium is, please?
Yeah, neither I don't know what Selenium is.
Okay, Selenium is a Python library that it was created to web development testing, and it was supposed to make easy to a web developer to test that his web actually works, and it can press buttons, scroll down, up, and it's really using web scraping that you usually do. If it can be done, you use the API to do web scraping, but if you have like a complicated JavaScript framework or something like that, you use Selenium. For example, web pages that kind of protect the data, such as I don't know, IMB, for example. They implement like several ways to avoid people to web scraping their data, but it can be done with Selenium because it emulates like a real person use.
That sounds very interesting, because as you say, this is for testing web development, kind of emulating with when a human is clicking the buttons and everything. Yes. So it is exactly that. My main question here is that at some point, I guess, Google Notebook will have this spam control, right?
Yes.
I mean, this kind of button that says check if you are human or not, and then you need to do some tests. I don't know. Is that included in Google Colab? Pablo,
yes. As far as I remember, on the free version, if you run the code on the browser, at a certain point, if you're not moving the browser or moving the cursor and so on, they're gonna ask for you. So click OK if you're connected. That's my point. But this is on free version. But you just click OK, so it's not a test like something like that. So it's still easy, I think.
Okay. But this, thanks, Curro. I think that was a very interesting point. This is left for people to try. Yeah,
it's a very interesting point.
Let's see. Okay, so some more questions from the audience. No? Okay. So my point for the discussion here would be, this looks great. Which other kind of molecular simulation software do you think, Pablo, would be interesting to try here? Because in your paper, you report about molecular dynamics, also about AlphaFold. But do you think there are other interesting options? I mean, in molecular simulation software in general.
No, I think the one interesting that is going to be great is going to use some enhanced sampling methods on Google Colab. For example, if you can use the OpenMM together with Plummet and do metadynamic calculation, umbrella sampling simulation, this is going to be great. People are need that. People are using a lot of the enhanced sampling methods. So I think this is one thing that in the future, I hope we are going to use on Google Colab too.
Oh, okay. Let's say somebody wants to try that. She should implement everything from scratch on the notebook, but I guess at least with the resources that Google Colab provides, would be that enough? Should he or she do the technique using I think the word was strides that you mentioned before?
Exactly, that's the whole point. I would say that, or else people can start with our notebooks because it's there, it's ready to run dynamics, and then you just need to implement the Plummet part. For example, I'm saying the metadynamics example here, but it's just because I think if I'm not wrong, I think there are an option with OpenMM to use Plummet. Okay,
sorry?
So there are options on OpenMM to use Plummet.
Okay.
Plummet.
Okay.
And then I think this you can just adapt it for your case. For example, in Plummet, and you can adapt to use with our scripts. It's don't need to start from scratch because the molecular dynamics code is there. You see my point?
Right. Yeah. Exactly. Okay.
But and not only that, for example, there are this Gaussian accelerator molecular dynamics simulation. It's a very good enhanced sampling method, and maybe in the future we can implement on OpenMM too and in Colab, and then you can have this enhanced sampling method ready for the people to use on Google Colab.
Yeah, exactly. So you mean it would be great, not just making the software available, because, for instance, let's say somebody needs to use GrowMax. Then he or she goes to the repository, downloads the code, but then he or she needs to go to the supercomputer, run the code, and this can be a nightmare. But it will be much better if everything can be packed or accessed in a very easy way, as you did, so that people easily get the notebook. Okay. I have the feeling that if people want their software to be kind of widely used, this is the way to go, right?
Exactly. Yeah, you got it. This is the whole point. In an easy way, you don't need to spend a lot of time to compiling software and so on. It's one click, you can install the dependencies, and then it's ready for you to use.
Right. It is software plus computational resources, which is
exactly.
Okay. More questions from the audience? Okay, no more questions. I think we cover most of the points here. Some questions from your side, Pablo?
No. I want to thank you for the invitation. It's great to talk with you. I'm happy that you are you have interest in this our work, because you spend a lot of time on that, and we want to people use that and give to us the feedback, some inputs, because now it's done, it's in the website, but when people are going to use, probably is going to have some issues and so on, and we need this input to improve our code and make it better and make it rain.
And make it rain, exactly.
Yeah, exactly.
Exactly. By the way, this is just perhaps a stupid question, but where does the inspiration for Make It Rain come? Because you are in California and it never rains in the south of California like the sun, or why?
It's an excellent point. Yes, in California, it's you have 300 days of sun during the year. So when it rains here, it rains for 10 minutes and that's it. And for example, this year we had 3 days of rain, only.
Only.
But the make it rain is for the meme. You know the meme that the guys make it rain with the money.
Okay. Yeah, exactly.
And then we are discussing together, me and my former research fellows, and then they said, we are going to make it rain with this tool. And then we said, yeah, make it rain. And then that's the name.
This is, by the way, in the paper, in the, let's say, the cover logo, you have this kind of bag with the money and raining.
Yeah, exactly, you got it. On the cover art, yes.
Okay, that's very interesting because in Murcia, in our region, in the south of Spain, and in Almeria, is kind of very similar situation. Okay.
Oh, really? So, you don't have?
In Murcia and in Almeria, and perhaps in Granada is the same. I don't know, but we are very close. But I can say that in Murcia is the same. We don't have the song like you, but it's kind of very similar.
Oh,
I don't remember.
It's cold now, right now, or not?
From my point of view, not. I mean, now I don't know if we have. I'm going to check. Kind of. We have 12 degrees Celsius. I don't know in Fahrenheit, but I don't know how to.
No, but I use the 3 degrees Celsius. I cannot understand Fahrenheit. It's crazy this Fahrenheit stuff. But I'm using here in California. We are going to start the winter, but we still have 31 degrees.
oh man, 31 degrees.
Yeah, exactly. And we are going to start the winter.
Oh man, it's hard. It must be hard. Okay. Yeah. Well, Pablo, so if there are no more questions from the audience, okay, I think we can conclude. So thanks, Pablo, and thanks everybody for being here in this very interesting journal club. Well, we have a comment from Sharania. It is a great initiative. As an academician, we are much obliged. Thank you both, Horacio, for suggesting and Pablo for his fruitful effort. Sure, I will use the platform. If struck anything, me and Wild might write you. What do you say, Pablo?
No, I just say thank you, and we are very glad to hear that, because every time that people send to us some questions or issues, and the people are using say, thank you so much for that. We need some tool, because this is exactly what we wanted in the beginning when we start this work. So we want the people use and the people have access to that, because it's important. Everyone has access to science and to do a good work. So that's our main goal, and we are very happy to hear that. Thank you so much. And please, if you have any question, write to me. We have the issue section on GitHub. Just you can write there, and you're gonna be happy to reply you, because we need these inputs from you.
Okay, excellent. Some other comment? No? I think it's very important, because you are doing not only great science, okay, but thinking about everybody else, and giving all the software to the public, but not only the software, but the access to the hardware. Okay, not everybody thinks about this. So very, very good point. Okay, so thanks a lot, everybody, for being here today. And it was a very interesting discussion. I have some other pending 1,000 questions for the next time, because I wanted to go into the business model of this idea, but that will be for next time. So thanks a lot, and bye-bye. And I hope to see you again in another future journal club.
Sure. Thank you so much for the invitation. I'm very happy to be here. Thank you, all the people here. Thank you, Horacio. And I hope to see you again soon. And see you guys. Thank you.
See you. Bye-bye, everybody.
And make it rain.
Make it rain. Exactly. Make it rain. And more in California. Bye-bye.
Yeah. Bye-bye.
Gracias por estar ahí y por escuchar este podcast. Os recuerdo que en las notas del episodio tenéis los detalles sobre muchas de las cosas que hemos hablado hoy y también un formulario donde si quieres puedes opinar sobre el podcast, para bien o para mal, como quieras, estás en todo tu derecho, y también sugerir si quieres un próximo entrevistado o tema que está relacionado con la investigación, claro, pues tu opinión me parece muy importante, tanto a mí como a toda la audiencia de este podcast que va creciendo y que va contando muchas cosas interesantes. También comentar que si te interesa alguna de las técnicas que hemos mencionado hoy de manera muy breve en el podcast, me puedes contactar directamente y te puedo dar más detalles. Y por último, si te ha gustado, te agradecería muchísimo que lo recomendases a quien veas que le puede interesar y difundirlo por las redes sociales o donde sea. Y nada, y si estás en Apple Podcast, pues ponernos ahí 5 estrellas o 4 como quieras. Siempre viene bien. Muchas gracias. Hasta luego.